Welcome to the demo for the encloud encryption CLI. Developers and organizations require cheap and secure cloud storage. However, current storage solutions are onerously expensive for larger datasets and require trust in the cloud provider to encrypt data and manage the keys. The encloud CLI leverages best-in-class envelope encryption and is designed to handle large file uploads. The CLI can be easily plugged into CI/CD tooling and data pipelines.
Welcome to the demo for the encloud CLI. The encloud CLI is an easy-to-use tool and has four basic commands. Users can generate plain text key encryption keys in RSA or ECIES format. Additionally, users can use keys derived from other tools, including encloud's non-custodial KMS, for which the demo is separately recorded. To generate keys, users can simply run the generate key pair command. This generates an asymmetric key in either ECIS or RSA schemes. Users can use the upload command where they're required to provide a public key, a file name, and a data encryption key scheme. Remember that encloud uses envelope encryption, where a key encryption key is used to encrypt metadata associated with the file. A data encryption key is actually used to encrypt the data. This is the best practice in cloud security, and we are the only providers to offer this in the filecoin ecosystem. On triggering the upload command, a request is sent out using the S3 API, the backend, to pin the data on filecoin. The data is first encrypted, and the metadata for it is written on a local store. Once the data is onboarded to S3, S3 responds back with metadata related to the success of the transaction, including the content identifier and various other metadata from filecoin. Once the data is uploaded, the user can see a list of all files that they have historically uploaded using the list command. For this, they need to provide the public key, that is the key encryption public key. The user can then see a list of all files that they have historically uploaded using the specific key encryption key pair. The metadata includes an internal unique identifier for the file, a hash of the public key, file metadata, and the content identifier of the file that is uploaded onto filecoin, a data encryption key, and the key and data encryption key types. Finally, the user can retrieve the data. To retrieve the data, the user needs to provide their public key, their private key, and the unique identifier of the file that they're trying to fetch. The key encryption key public and private key pairs are both used in the retrieve process as part of the envelope encryption scheme. The public key is used to query the specific metadata, and the private key is used to decrypt the data encryption key, which is then used to decrypt the bytes retrieved from filecoin. As you can see, the data is retrieved and stored on the local file system.